Fine.
Yep, looks good and recording started.
Perfect. Thank you. All right. So I am Natalie Hoydel. I'm a vegetable crops educator with Extension. And this is our winter webinar series. We have been talking about all kinds of different things. We've kind of started with planning, um, crop planning, what kinds of things are right for your farm, whether it's fruit or high tunnels. Now we're sort of in the middle of the season. Thinking about growing our crops. And having balanced fertility is a really, really important aspect of growing crops successfully. Next week, we're going to shift gears and start talking more about post-harvest um, and tools and techniques for making sure you have good shelf life and quality after you put in all of the work that it takes to grow fruits and vegetables. So today is all about soil. And before we jump in and talk specifically about soil tests, um, let's like zoom out a little bit and talk about soil in general and the role that a soil test plays in giving you a really comprehensive sort of understanding of your soil. So a soil test is really just like a snapshot in time of the chemical properties of your soil, which is great. But soil is much more dynamic and complex than that. Um, so I find it really helpful to step way back and just kind of think about the function of your soil. So, were your plants healthy last year? What were some of the that you had? Um, did you have stunted plants? Did you have flooding in your fields? Did you have compaction issues? These are all sort of part of the picture of approaching soil and soil health. And a lot of learning about our soils comes from interacting with it. So, what can you see? What can you feel? What can you smell when you're out interacting with your soil? So, we're looking for physical aspects of soil health, things like crusting, compaction, um, good soil structure. Ideally, when you pull roots out of the soil, they look something like this. They're covered in little balls called soil aggregates that sort of stick together into larger and larger aggregates. Um, Ideally, you have good structure, you don't have a lot of compaction. We're also looking for signs of life, some of the biological health of our soil. We like to see at least three different types of soil life when we dig a hole. So that could be earthworms, that could be insects, that could be mycorrhizal fungi. Um, we want to see life in our soil. So this is something you can do early in the season as you're going out to take your soil test. In addition to just that snapshot that we're seeing of the chemistry of your soil, we're looking at the bigger picture of soil health. And so just some of the theory behind that, I guess. So soil health is this combination of physical, biological, and chemical. So the physical things like texture, structure, aggregation, compaction, and infiltration. The biology could be like the microbiology that we can't see, things like microbes. It could be larger biology, like insects and earthworms, pest insects, beneficials. Um, and that biology really contributes to nutrient cycling in our soil. And then the chemical piece is pH, nutrients, and potentially contaminants. So soil health is sort of at the nexus of these things, and a soil test is mostly just looking at the chemical. And these things really reinforce each other. So for just some examples of how these different functions of soil work together, when you have more organic matter and when you're reducing tillage, we tend to see more microbial diversity. We have more, when we put organic matter into the soil, we're feeding the microbes. Those microbes, in turn, are doing a lot of work for us. They mineralize nitrogen, phosphorus, sulfur, other types of nutrients. So they take those nutrients that are bound up and they make them available to plants. Things like mycorrhizal fungi, they can, again, like make nutrients available to plants. They can decrease the loss of nutrients in the soil. So these things are all very connected. And when we take a soil sample, we're looking at a few things. Um, we're getting this snapshot of things that we don't have a lot of control over, but influence our management. So things like soil texture, organic matter is something we can start to influence a little bit more. Same with the pH or acidity of the soil. And then we're looking at the nutrients, which we can much more easily manage by adding things to the soil. So we start with taking a soil sample. You can really do this anytime. Ideally, you do it in the spring before planting or in the fall at the very end of the season. I really like to do it in the fall, just because it gives you time. If you do it in the spring, you're often waiting for the lab. The lab is super busy. They're getting tons and tons of samples from gardeners, and you don't have a lot of time to make decisions and to buy things. In the fall, you have a lot more time to sit down and make a plan, to ask questions, to look for the inputs that you need. And ideally, you would do that at the same time, roughly every year, every couple years, just so you're making kind of an apples to apples comparison. And you want a representative sample from across your fields. So we generally sample soil from the top 6 inches. So a soil core, like in the picture on the right, you see someone holding up a soil core with about 6 inches of soil in it. Those are really nice because it gives you this like perfect 6-inch core looking at the nutrients across that area where plant roots are most likely to grow. You can totally do this with a small shovel or a hand trowel too. You just have to be careful to take a slice vertically versus just sort of scooping off the top. So I like to dig a little hole and then put my hand in it and stick the trowel down to like put my hand over the top and scoop it out to make sure I'm getting that full 6-inch slice. And then this picture on the left is just a couple different fields with dots all over them, showing you want to get sort of a representative picture of your whole field. So in the first picture, we have a random assortment of dots. In the second picture, it's like a Z shape. The picture on the bottom, you've got raised beds and someone walking down and taking a couple cores from each raised bed. And the idea of that is that soils are really diverse. If you sample in one spot, it might be a little bit different than another spot. So it's good to have kind of a mix of samples from across your planting area. People often ask me, how many samples should I take? Generally, it's like 15 to 20 per area. And the number of areas you sample separately really depends on what you're going to manage. So if you're just going to do the same thing to all your fields regardless, and just do one sample, if you're really going to treat one field differently than another, in terms of how much you're applying and what you're applying, then sample them separately. I always also do a high tunnel separately. So that photo in the middle just shows a high tunnel and some beds in it, and then little dots along each bed. So you would do a high tunnel separately just because the fertility is going to be a lot different in there. So then you're going to get a piece of paper in the mail or in your email that looks something like this. This is a University of Minnesota soil test report for farm and field. Sometimes people will do a lawn and garden soil test. On a small scale, it can be nice to get recommendations in pounds per 100 square feet. That's the benefit of doing a yard and garden test if you're really small. So it's not so overwhelming to like convert down from pounds per acre. But do know that the part in the middle where it's sort of giving you a range of like, is this, especially for phosphorus and potassium, like, is it medium? Is it high? Is it very high? That range is just ever so slightly different for gardeners versus farmers, with the idea that farmers are generally farming more intensively, their yields are higher, and their crops are taking up more nutrients. Once I go through this, I'll show some examples from other labs. You can totally use a private lab as well. You don't have to use the University of Minnesota. What I like about the University of Minnesota is that the recommendations are really, really specifically targeted to Minnesota soils. So this is like the big screenshot of a soil test, and we're going to go through it piece by piece to explain what the different tests mean, and how to understand them in your context. So we've got this bar across the top with all these different measurements: soil texture, organic matter, pH, and we're going to go through that piece by piece. And I am seeing your comments in the chat, and we will definitely address those two things. Great, so we're going to start with soil texture. This is maybe not my favorite part about this test, is you can pay extra to get a full soil texture analysis where it would say like silty loam or clay loam or something. But on a basic test, they're really just like feeling the soil texture and saying whether it's fine, medium, or coarse. So fine would be a soil with more clay in it. Coarse would be a soil with more sand in it, and medium is somewhere in between. And basically, soil is made up of mineral matter, air, water, and organic matter. And so the mineral matter is just like kind of ground up rocks, and those rocks are different sizes. And so sand is the largest size. You've got coarse sand. So on the right here, we have these concentric circles. We have this big yellow circle that is coarse sand. The medium sand particle would be, maybe a third of the size of that. Fine sand would be about like a third of the size of that. And then you've got silt, which is this little red circle, super small. And then clay, you can barely see. It's like a pinprick comparatively. And so when you have sand, you've got really big particles, and it's really easy for water to move through. When you've got clay, tiny, tiny particles all smushed together, way more surface area. And so there are more places for things to stick. Those things could be nutrients, they could be organic matter. It's also going to be slower for water to move through or nutrients to leach down through that soil. And so it's really important to know your soil texture, because the way you manage your soil is going to be different depending on your soil texture. A clay soil is going to have a higher water holding capacity. It's going to store more water. It's also going to store more nutrients. Clay soils can become compact. They can form a crust on top. That's fairly unlikely with sand. Sand does not necessarily compact as easily. It also doesn't hold water or nutrients very well. So you have to water much more frequently. You have to be a lot more careful about nutrient losses. So often people will split applications of inputs throughout the season. Clay soils might be more likely to build up some salinity if you're using high salinity inputs, like certain composts or manures, especially in a high tunnel. There's more of a risk of building up salts. It's less likely in a sand because there are just fewer places for those salts to stick. And a clay soil is going to warm up a little more slowly in the spring, so you might plant a little bit later. Like I said earlier, this is one of the things that you can't really change on a soil test, at least like in a human lifetime. Your soil texture is not going to change. So it's more something that you learn and you adapt to, versus try to change. The next thing on your soil test is organic matter. So organic matter is just basically anything that is or was living in your soil. So it could be your plant residues that have broken down, any mulches that you've added to the soil, compost that you've added to the soil. And that organic matter is a reservoir for carbon and nitrogen in your soil. Organic matter helps with aeration. It helps with water infiltration. It can help with soil structure, holds water. And so organic matter is really important for soil health. And in general, we have these classifications in Minnesota. So in a Minnesota soil, low organic matter would be less than 3, medium would be 3 to 4.5, and high would be over 4.5. But there's a big caveat there that it really depends on your soil texture. So 3% organic matter in a sandy soil would actually be pretty good. So again, there are less places for organic matter to stick. and to bind in a sandy soil. So it's much harder to build organic matter in sand. In a clay soil, 3 might be kind of low. So it really depends on your context. Adding organic matter to the soil, you can do that through compost, organic matter, either living or dead. That could be things like cover crops or mulches, manure. A lot of organic fertilizers will add some organic matter, so we'll talk about that at the end. Things like bone meal, blood meal, soybean meal. And just to give you like a little bit more nuanced, kind of a spectrum of organic matter. Organic matter in Minnesota soils can be as low as 1 or less, up to maybe 20-ish% in extreme cases. So low 1 to 3. The average Minnesota farm soil, this is based on samples submitted to the soil lab at the University of Minnesota, is about 3.95%. If we look at vegetable farms from our 100 farm study, organic matter was about 4.7% on vegetable farms. These farms are smaller, they can be managed more intensively with more inputs. A native prairie in Minnesota might have 4 to 7% organic matter. So I think that's a really helpful reference point as we're looking at agricultural soils. High tunnels in our 100 Farms project, we're at 6.3, so way higher than fields. People tend to put a lot of inputs in their high tunnels. In 2022, I did a study of, I think 22 community gardens with Ramsey County, and we were at 9.6% organic matter, and the raised beds in those community gardens had 17.6. So we tend to see really pretty high organic matter in gardens in Minnesota, in part because we are like constantly adding compost and mulches to those soils. Once we hit 20%, we don't actually consider a soil anymore. It becomes like an organic soil, sort of like a peat bog. It's not a peat bog because that's a really specific ecosystem, but it's not even really a soil anymore. And that has some implications for management, for water holding capacity. So the idea that more organic matter is always good is not necessarily accurate. Some organic matter is great, but sometimes if we're putting a ton of compost in the soil, that can be associated with high salts. It can result in a nutrient imbalance. Often that means we end up with a lot of phosphorus in the soil. And if we have so much organic matter that it is causing issues with irrigation. So sometimes in heavy compost systems, we see this like separation of layers where we have this thick layer of compost and then there's soil underneath it. And that compost can dry out and become really hard to re-wet, and irrigation becomes a challenge. So we'll see, especially in raised beds, like you'll hold a hose over the raised bed and you'll see the water pouring out the bottom, but the soil inside is still dry. So making sure if you are like farming or gardening with a raised bed system that you have some soil in there and it's not just compost, is pretty important. All right, the next thing we're going to see on a soil test is the pH. So this is the measure of acidity in the soil. And ideally for vegetables, we're somewhere between 6 and 7. A lot of Minnesota soils are just slightly over 7, especially in urban areas. There are also soils that are below that. And really this range is ideal because that's the spot where plants can most readily access nutrients. So we've got a graph here, all these different plant nutrients: nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, iron, manganese, boron, copper, and zinc, and molybdenum, and the ranges at which they're most available based on the pH of the soil. And so that sweet spot where your plants are able to access all of these nutrients fairly well is really from 6 to 7. If your pH is too low, your soil test will actually come with a specific recommendation for adding lime to bring that pH up. If your pH is too high, sulfur can be an option to bring it down. Often we see pH creep up when we use a ton of inputs in the garden, and sometimes the answer is to minimize those amendments rather than to add more things to bring the pH down. But if your pH is getting above 7.5, it can be worth considering some sulfur. All right, so those are some of the things we see on a soil test that are more about, that are not nutrient related. And now we're going to shift and look at the things that are nutrient related on a soil test. So there are 16 essential plant nutrients. So carbon, hydrogen, and oxygen plants are getting from the air and water. Our macronutrients are nitrogen, phosphorus, and potassium. And plants are using these in large quantities every year. So we're pulling them out of the soil. Those nutrients are going into our plants and we're harvesting them. And so we're taking those nutrients out in large quantities, which means that we also have to find ways to put them back into the soil to keep growing plants. Secondary macronutrients are sulfur, calcium, and magnesium. Most Minnesota soils have plenty of these, and our plants are not using them in really large quantities. Sometimes we do see sulfur deficiencies. We very rarely see calcium or magnesium deficiencies. And then the micronutrients are things that plants are using in very small quantities. So boron, chlorine, copper, iron, manganese, molybdenum, nickel, and zinc. And most of us in Minnesota live and grow things in soils that had glaciers on them. And those glaciers helped to grind down bedrock and put a lot of micronutrients into our soils. And so we're really lucky to grow food in a place where we have pretty abundant micronutrients. And for the most part, people don't test for these things on soil tests, specifically in Minnesota, because they tend to be really abundant. If you're noticing some really specific deficiencies, that's when you might consider testing. So let's look at those macronutrients. Nitrogen tends to be moved into green growth, into leaves and shoots. Nitrogen can be, it's in the soil, but it's not always available to plants. So if it's in its organic form, plants can't use it. It has to be converted into nitrate or ammonium. It moves around a whole lot. So it's really hard to capture on a soil test. It also can get into our groundwater, and so it's important to be not over applying nitrogen. When we see signs of deficiency, we don't have enough nitrogen, the first thing we see is like general yellowing. We're seeing kind of yellow plants, and they're most yellow in the bottom leaves. Plants are really good at moving nitrogen up to the newer leaves. So we see that deficiency lower down, and our plants are often stunted. And so we don't usually include nitrate on a soil test. So in my example soil test here, there is nitrate, but if you do a basic soil test, you are not going to see this. And the reason for that is a soil test is not a great way to actually know how much nitrogen is in your soil. In part because it's moving around, it's like going through the nitrogen cycle, and a soil test is just like a snapshot in time. So instead, we actually use organic matter as a proxy for how much nitrogen our soil can hold. And as a result, the recommendation on your soil test for nitrogen fertilizer is going to be based on your organic matter for the most part, unless you pay for a nitrate test, which is something that I actually have started to do more often, not to specifically make a nitrogen recommendation, but to get a little more insight. So if you're doing a soil test in the fall, I think it can be worth doing a nitrate test just to see like how much plant available nitrogen is sitting in the soil after you've harvested. And I often see in gardens and vegetable farms that there's a lot of nitrate left over. And so that can be a clue that you are over applying nitrogen in your garden or on your farm. If you're growing in a high tunnel, I also do a nitrate test in the spring. And I use that as a nitrogen credit. Phosphorus is the next thing you'll see on your soil test. Phosphorus helps plants create proteins, helps them store and transport energy. Phosphorus is also a water quality concern, and we want to be really careful about not over applying. Something you might see if you plant really early is that phosphorus is not mobile in cold soil. So every once in a while, like in these pictures here, we've got pepper plants with purple leaves. Purple leaves are a sign of a phosphorus deficiency, but um, sometimes it's just too cold and the plant can't access it. And as soon as the soil warms up a little bit, those symptoms go away unless there's an actual phosphorus deficiency. So purple leaves can be a sign, but base your phosphorus applications on your soil test. So we have two ways of measuring phosphorus in Minnesota, and this is going to be based on the pH of your soil. So just purely from like in the laboratory, one test is more effective at accurately estimating when the pH is lower. That's the Bray test. And the Olsen test more effectively estimates soil phosphorus when the pH is high, above 7.3. So you're going to have at least Bray. So they always run the Bray test. If the Olsen test is listed, go with the Olsen test. And so we've got these categories of low, medium, high, very high, and your soil test will tell you where you fall in that. In general, we have really high phosphorus on farms in Minnesota. So again, the average, going back to that soil lab database, the average farm in Minnesota has 39 parts per million phosphorus, which is high. The average lawn and garden sample has 64 parts per million, which is really, really high. The average vegetable farm in our 100 Farms project had 89 parts per million. So that's like twice as high as high. Average Ramsey County community garden had 124. So like that's like 3 times as high. And then our high tunnels tend to have a lot more phosphorus. And so we generally don't need more phosphorus in our soils. There are certainly some of you who will, but most of you probably do not need more phosphorus. And that does matter because phosphorus is a limiting nutrient in freshwater ecosystems. And when phosphorus leaves our farm, usually through surface runoff and erosion, but potentially also through leaching, that can not be great for our freshwater ecosystems. And especially if you're in an urban area and your garden is near a storm drain, or you're really close to a water body, you're farming near a lake or a river, you want to be really extra careful. Right, our final macronutrient, potassium. Potassium is really important in fruit set, especially for heavy fruiting crops like tomatoes. Plants use a ton of potassium as they're flowering and fruiting. Occasionally, too much potassium can get in the way of other nutrient uptake. I think we very rarely see that. The sign of deficiency tends to be yellowing of the leaves, but it's a little different than nitrogen. So nitrogen, we see uniformly yellow lower leaves. And in potassium, we see the edges of the leaves turning yellow when there's not enough potassium present. And in my experience, potassium is pretty variable on Minnesota vegetable farms. Sometimes it's high, sometimes it's low. In high tunnels, we need a lot of potassium, so it's easier to become deficient. And here's that range. And again, your soil test is going to tell you where you fall on that range. All right, so what about these other things? Should we be doing the additional tests? There are all these add-on tests you can choose to do when you take a soil test. Contaminants, I think it's worth testing for lead, especially in an urban area or if you're farming like or gardening near the foundation of an old building that may have had lead paint. You don't have to continue to test for lead, but it's worth doing once. The secondary nutrients, again, these are generally not lacking in Minnesota soils. You could maybe test for these things once, just if you want peace of mind, but don't feel like you need to. And then the micronutrients, we really only recommend testing if you're seeing deficiency symptoms. And again, you're welcome to test these things. There's no harm in doing it. It just costs extra money. And so generally, it's not worth it. Maybe boron if you grow a lot of brassicas. And again, maybe sulfur, just because sometimes we do see some sulfur deficiencies. Right, I wanted to give just a couple examples of what a report might look like from other labs. So I chose a couple of Midwest laboratories. So one is AgVise, and it's it's busy. It looks a bit different, but in general, you're seeing the same things reported. So here's a zoomed in version. On the left, we just have a screenshot of the whole test. On the right, we have the different nutrients listed: nitrate, phosphorus, potassium, and you're seeing the amount, and then they have their own sort of scale for showing whether something is low, medium, high. Here's one from Midwest Labs. They basically just give you, again, the reading, and then instead of like a chart, they just say like L for low, M for medium, H for high, VH for very high. So it's fine to use these labs. The reports look a little bit different, and they generally like are testing for the same kinds of things. So we're gonna transition now. That was just like looking at your soil test into making a fertility plan. Um, does anyone have any questions just to clarify that first part about looking at your soil test? And I can't see raised hands or anything actually, so maybe put them in the chat or unmute.
Natalie, I just had a quick question about if you get testing done and you need assistance for interpretation, you might have already said this. What are good resources to go to if we're unsure what we're looking at?
Yeah, so that's kind of what this next part is going to be, sort of. It's like, how do we interpret this? How do we make a plan from it? But you can always reach out if you are a gardener. You can go to Ask a Master Gardener from the University of Minnesota, and there are master gardeners who can help look at your soil test. If you're a farmer, um, hopefully you live in a county that has the local extension educator. And I would reach out to them first. I know in your county, Mary's awesome. She's really good at, she knows a lot about soils. She would be super helpful. And then if you're a farmer and you don't have a local educator in your county, you can reach out to me. So, all right, let's continue. So hopefully, and we have some web pages too that kind of run through how to interpret your soil test. We'll be posting some articles in our fruit and veg newsletter as well. So that first part was just looking at your soil test. What do the numbers mean? And now we're going to move into actually making meaning from that and making a fertility plan. So let's start by, before we get super specific, just talk about different nutrient sources that you could add to your fields. So we have these two broad categories of inorganic and organic fertilizers, and that doesn't have anything to do with certification. It's more the form that these nutrients are in. So inorganic fertilizers would be like typically manufactured or mined, and the nutrients are already in plant available form. Organic fertilizers, your nutrients are bound up in carbon, basically. So manure, compost, for example. And plants utilize nutrients in their inorganic form. So for nitrogen, plants can access nitrate or ammonium, and they rely on microbes to break down the nitrogen that's like bound up in manure or whatever else and turn it into those forms. So inorganic fertilizers, those nutrients are immediately available. They don't need microbes to transform them. They tend to be uniform, so what's printed on that bag, you should be able to trust. It's really easy to calculate how much of each nutrient you're putting in because it's printed right there on the bag, and they tend to be more concentrated. And so the upside of that is you don't have to apply as much to meet your plant nutrient needs. The downside is there's more potential for loss to the environment. And so the NPK will be printed on the bag: nitrogen, phosphorus, potassium. It's listed as 3 numbers. So here's an example of a fertilizer bag, really generic all-purpose fertilizer, 10, 10, 10. So those numbers are a percentage. So in a 50-pound bag, 10, 10, 10, you've got 10% nitrogen, 10% P2O5, 10% K2O. Those are the forms that plants are using phosphorus and potassium. So in a 50-pound bag, 10% would be 5 pounds. 10% of 50 is 5. So you have 5 pounds of nitrogen, 5 pounds of P2O5, 5 pounds of K2O in that bag. Organic fertilizers are a little trickier. So again, this means chemically organic, not necessarily certified. The benefit of using organic fertilizers is that you're improving the soil health. You're adding organic matter to the soil. These tend to be derived from plant or animal sources. So again, things like compost, manure. We also have a lot of organic fertilizers that are byproducts. So like fish waste, bone meal, blood meal. And some of these are really, really specific. And there are 2 pictures on the top. One is just like a compost pile. The second is a bag of bone meal that does have that labeled NPK ratio. So organic fertilizers can have that. What's tricky is when we're using these more bulk products like manure or compost, it can be challenging to match plant needs. It's also really challenging to know how much you're adding. I guess one other thing that makes it a little trickier is that your compost might contain weed seeds or pathogens, and so, or your manure. It's important that you're getting compost that's been properly composted and that you know like where your manure is coming from. So something that's tricky about really relying on just compost or just manure is that they're often high in phosphorus and potassium and low in nitrogen. And often our plants need a lot of nitrogen and our soils already have plenty of phosphorus. So some example estimates that you'll remember, the synthetic one we looked at was a 10-10-10. Yard waste compost might be like a 1.3 to 0.4 to 0.4 or a 2-1-1. So the concentrations are much lower. And this is a little bit misleading because yard waste compost technically has more nitrogen than phosphorus and potassium, but most of that nitrogen is not going to be available for your plants to use because it's so bound up in organic matter. So what inputs are best? There's not a universal answer to this. I like to tell people to try to start with what's local, what's sustainably produced. Maybe your county or your town makes municipal compost. Compost is a great fit if your soil can handle a little bit more phosphorus. If your phosphorus is already really high, you may want to hold back a little bit. That's especially true of compost and manure. Think about byproducts, think about like fish waste. If you live in a community where there's fish processing, food scraps, think about manure from your neighbors, or there are a lot of local companies that sell manure products. And then we also want to think about supplemental products that are more specifically just adding the nutrients you need. So if you have plenty of phosphorus in your soil and you need some nitrogen, things like blood meal or feather meal will provide that targeted nitrogen without the extra stuff. If you need some potassium, but you don't need more phosphorus, potassium sulfate can be a good option. So that's sort of general, but what do we do specifically for your soil? So your soil test will give you a recommendation. And if you're using the U of M lab, and I know this is true of other labs as well, you can usually choose like 2 or 3 crops that you are going to grow. So here's an example screenshot from a soil test for cabbage. So this person, based on their soil test, needs 140 pounds of nitrogen and 50 pounds of potassium, no phosphorus. So how do we do that? And actually, before we do that, I want to say the soil test will only give you 2 or 3 crops. So if you need more crops or a different crop that's not on there, there is a nutrient management for commercial fruit and vegetable crops in Minnesota guide. And this guide has recommendations for nitrogen, phosphorus, and potassium for a bunch of different crops. And you do have to, it takes a little bit of time. You would have to go through and say, okay, I want to grow cucumber. I have medium organic matter. You follow the cucumber line over. and it says, okay, I need 80 pounds of nitrogen for my cucumber. And then the next page does the same thing for potassium and phosphorus. So you can come up with your own using that guide. Here's an example of what it would look like for a vegetable garden. So this soil test is saying 0.15 pounds of nitrogen per 100 square feet. So it is, if you're growing in like small raised garden plots, I think this is a lot easier than trying to come down from pounds per acre. So how do we actually do that? Basically, you are going to divide the total amount of nitrogen that you need for the nutrient by the percentage in the product. So let's say we're using this guided nitrogen product. It's 1200. I would divide 0.15 pounds, that's my need per 100 square feet, by 0.12. That means for my 100 square foot area, I need 120, no, I need 1 pound and a quarter, 1.25 pounds of product for 100 square feet. And this is where like 8th grade math will catch up with you, and you can, it's like, I can never remember if I'm dividing or multiplying. So just making sure you're going back to guidelines and like trusting your gut if things look way, way off is important, because it's easy to accidentally multiply or divide, but we're dividing by the percentage in the product. For a farm, this farmer needs 140 pounds of nitrogen per acre of cabbage. So we're going to do the same thing. We're going to divide by 0.12, and it's a much larger quantity, right? Because it's for an acre. So this farmer would need 1,166 pounds if they're just using this product to meet their nitrogen needs. So you basically would do that for nitrogen, phosphorus, and potassium. But the challenge is finding the right balance. So let's say, sorry, I keep switching up my examples here, but here's a similar soil test. So this person wants to grow sunflowers, and they need a lot of nitrogen, a little bit of potassium, and no phosphorus. So if they were to use this 10-10-10, you could divide 150 by 0.1, and it would give you, sorry, that is a little, that's not quite right. It would say 1,500 pounds of product. So you could do that, but it would also give you way too much phosphorus and way too much potassium. So the challenge here is to kind of find this balance. So let's say like your need is a lot of nitrogen, some phosphorus, no potassium. If we compare that to yard waste compost, we are not meeting that need with yard waste compost. We're getting not enough nitrogen, too much phosphorus, and too much potassium. If we do a 10-10-10, we see that same thing happen. We can meet our nitrogen needs, but we way overshoot our phosphorus and potassium needs. And so this is where, again, those more concentrated products like a feather meal or potassium sulfate can come in to bridge that gap. So I've alluded to some of these. This tends to be the biggest challenge, is how do we add nitrogen into our farming and gardening systems without overdoing P and K. So I've mentioned things like blood meal. Some fish products tend to be really diverse in their ratios of NP and K. There are various crop products like soybean meal, peanut meal, alfalfa meal. Conventional growers could use some of these more concentrated forms of nitrogen, like really, really carefully applied urea, ammonium nitrate, ammonium sulfate. And I am a huge fan of cover crops for supplying nitrogen. If we go back to that example of using this guided nitrogen product for our nitrogen, more than 1,000 pounds of this per acre is a lot, and it's expensive. So when we use cover crops, we can often get like a 40-50 pound nitrogen credit from a cover crop, which can in some cases be most of our crop need. In some cases, that's like half of our crop need. So it's a really nice way to get some nitrogen into the system. We do have a calculator tool that people can use, where you put in your crop, the amount of space you're growing it in, you put in your soil test information, and then you're able to choose inputs from a drop-down menu. And you're choosing two things. You're usually starting with a balanced fertility source like a compost or a manure product, and then you can supplement it with more concentrated things like blood meal. And it's sort of a helpful tool, but it also really helps to have the basic kind of theory going into it. So you're not just like getting frustrated clicking all different combinations of things, because it will stop you. And it's it's not the perfect tool. We're getting there. But it will stop you. It'll say, like, let's say you need nitrogen and not a lot of phosphorus, and you choose like two different compost and manure sources. It will tell you this combination of inputs won't work, please. And it tells you why. This will result in too much phosphorus and not enough nitrogen. Please choose some options with more nitrogen and less phosphorus. The other kind of awkward thing is that it it may give you a negative potassium recommendation if you are applying too much potassium. So we could only choose to balance two nutrients, and we chose to balance nitrogen and phosphorus, and then potassium gets added in at the end. So where can you buy these products? There are agricultural cooperatives all over Minnesota that serve larger farmers, and small farmers and occasionally gardeners can buy products from them. They generally don't sell organic inputs, but they can be a nice place to, if you need lime, to either get lime, or they can connect you with someone local who spreads lime. You can buy pesticides, you can buy your more concentrated synthetic nitrogens like urea or ammonia. They can also just be places to call if you're looking for local connections. They're well connected to the ag communities, and so they can be a resource. There are a number of companies in Minnesota that do cater more to small farms and gardens. So in Woodbury, we've got Jordan's, the North Branch Mill up in North Branch, Marty Lawn and Feed in Monticello, the Vermilion Elevator by Hastings, Mid-State Supply in St. Cloud. There probably are others. These are like the places I've started to find. You'll be able to buy synthetic products there. Often you can buy Sustain, that's a composted poultry manure product. You can usually buy soybean meal, corn gluten meal. Those can be sources of nitrogen. Sometimes they have blood meal and feather meal. It might be expensive. And so often to get these more targeted nutrients, we do have to go online to places like Ohio Earth Foods, Seven Springs, Arbicore Organics. But these are some options for finding some of these things. I also recently learned that there are a couple of places that will do custom blends for you. So if you show them your soil test, they will go and like mix up a custom fertilizer blend that is balanced and meets the needs of your crops. So that's sort of a way to bypass the system and not have to do all these calculations yourself. So it's nice to know that that's an option if you would like to use it. And I'm going to end with just again saying like a caveat here. And I alluded to this earlier when I talked about compost, that let's say for composted manure, you might buy a bag of composted manure that's labeled 464. Not all of that nitrogen is going to be available in the first year. And so that makes the calculations kind of challenging too. It's usually 30 to 50% available in the first year, 15% in the second, sometimes even 15% in the third. So that's something to think about if you're primarily relying on like composted manure, is to kind of bring down the amount that you're getting in the first year, but also if you've been applying these products over the years, to factor that in, that you're still getting some nitrogen from those previous applications. So we will stop there and do some questions. I think this is like one of the hardest things because it just is like, go do math, good luck. But those resources are available to you if you're a Master Gardener. Again, Ask a Master Gardener line, your local educator can help. And I'm going to stop sharing here and see what questions people are asking. Okay, I'm gonna go through the chat. Keep adding stuff to the chat if you'd like. So yeah, the first question, soil phosphorus is very high. Again, this is really common. So the first thing again is not adding more phosphorus to that system. And unfortunately, there's not a lot we can do to bring those numbers down other than not adding more and just continuing to grow things in your garden. And as you harvest, you will very slowly bring those numbers down over time. When adding compost to raised beds, does that change or influence the prior sample? So if you previously took a soil sample and then you added a bunch of compost, that will influence your soil test. So continue to take soil tests from that bed. Lauren stuck the nutrient calculator in the chat. So Jeff says, I grow tomatoes in raised beds in a greenhouse, and you're always fighting the pH. Yes. So in a greenhouse, we often are. That 7.2 to 7.4, I think, is kind of right on the edge of like when it's worth dealing with it, I guess. 7 is ideal. If you get to 7.5, I think it's worth bringing it down. But yeah, you could start to add a little bit of sulfur to your soil. You could also think about in high tunnel, we tend to see the pH go up. And if you're going to be replacing that plastic at any point, like just leave the plastic off for the winter that year before you replace it. And having rainwater in your tunnel can help a little bit. But yes, I would say a little bit of sulfur, and it's better to do like a little bit every year, like 10 pounds across your whole high tunnel every year versus trying to do a ton at once. It's something that works slowly. The bacteria in the soil have to convert the sulfur into sulfuric acid, and that's what brings down the pH. So if everything is high on your soil test, what do you add? Jana, you could add nothing. And I think that's like the hardest thing to tell a farmer. We always want to do something. We always want to be like improving the soil. And often the answer is to do nothing, which is hard. But I think the sticking to some of the other soil health principles, like using cover crops, reducing tillage, those are going to do a lot more for your soil health in the long term than just like continuing to add compost because it feels like a good thing to do. Dana's asking specifically about peat moss. I'm not a fan of using peat moss, mostly just because it's like mined from really, really fragile ecosystems. And it releases a lot of carbon. So I really try to avoid it when possible. I think if your pH is high, using a little bit of sulfur is the route that I tend to direct people down rather than using peat moss. And actually the same for blueberries. It takes a lot of peat moss to bring the pH down. It takes less sulfur. So that's a trade-off. I mean, there are people who like to use it, but I think there are some consequences of that. Nathan's asking about hard water for irrigation. So yes, this is this is really tricky. So almost all of us in Minnesota have really hard water, unless you live on the North Shore, basically. And it can be a challenge for irrigation in a high tunnel. If you're just irrigating fields or garden beds, you don't need to worry about it. If you're in a high tunnel and you're only getting irrigation water, no rainwater, that's when it starts to be a problem. And it really depends how hard it is. So you want to test your irrigation water for both pH and alkalinity. And if your pH is like higher than 7.5, and your alkalinity is, it probably is going to be higher than 100. That's the ideal. If it's higher than maybe 200, I think it can be worth acidifying your irrigation water. And I'm going to see if I can find it really quick. So we have our fruit and vegetable newsletter, and there is an article in there about acidifying your irrigation water. I'm gonna link if I can find it. I found it. Okay, I'm gonna put it in here. So that is typically done with sulfuric acid. In a non-organic system, if you're certified organic, the option is to do it with citric acid. And it requires a lot of citric acid. So it's not super fun. It's kind of annoying to deal with, but it can potentially be helpful in a high tunnel. Well, adding gypsum now in, yeah, so we usually don't recommend adding gypsum in a high tunnel. We would usually recommend doing elemental sulfur, the really, really fine ground sulfur, in the fall for bringing down the pH. Well, we're still here. We've got 2 minutes. We can keep chatting and asking questions, but I'm just gonna launch the poll real quick. This is just a quick evaluation right in Zoom of the webinar. And we've got time for 1 or 2 more questions. Yeah, so Jeff's talking about lowering sodium in the greenhouse along with a good flush. Something to think about with a flush. So there are a couple things. So conventional wisdom has been to like flush the salts out of your high tunnel. Often our salts in our high tunnel are nitrate. So you want to make sure you don't have a ton of nitrate in your soil before you're flushing it out, just because that's going to go into groundwater. But also you want to make sure that your water is not really high in alkalinity. Because if it is, it's not going to be very effective. So it's better to like take the plastic off and let rainwater come through, or maybe do like a rainwater catchment situation and flood it with that. I would not spray lemon juice on your tomato seedlings. Is your calcium high and your pH high? Calcium and pH are high. So I guess just like spraying the seedlings with an acid isn't going to bring down the pH of the soil. Is it your soil or your potting soil that has the high pH and calcium? Dana, I can also just follow up with you one-on-one. Why don't we do that? Yeah, so I think spraying an acid on your seedlings isn't gonna like counteract the basic soil or like all the minerals in the soil. So I would say trying to address the soil is better than spraying something on the plants. All right. Well, thank you everybody for joining us today. Again, next week we're going to shift gears and talk about post-harvest. And I can stick around for another minute or 2 here if there are any additional questions. Got great question. So how often should you be retesting? Every 2 to 3 years is totally fine. In high tunnel, I say every year, but otherwise in fields and in gardens, every 2 to 3 years is great. Unless you do something drastic. Like if you if you do some major intervention, then you might want to test the next year. But otherwise, if you're doing things kind of the same every year, every couple years works. All right. Well, thanks everybody. Just